Here is another section of rib, and like any section through bone, bone has to be decalcified in order to make a proper cut through it, which means you take the gritty elements out of it, the crystalline elements, and then the bone actually becomes soft, and you could cut it like it was soft into very, very thin slices. This very much resembles the last piece of rib that we saw. We saw dense cortical bone out here with all of these holes being either blood vessels or part of the Haversian system, perhaps some Volkmann's canals. We could see some skeletal muscle out here. We could see some periosteum. We could see some endosteum on the inner surface. And we could see marrow as well. But in the last piece of bone, all we saw was a very dense piece of bone. Here we have the second type of bone, which is not as dense or cortical bone, and for that reason this is called spongy bone or cancellous bone. Some people call it membranous bone because it is composed chiefly of these little spicules or lines of bone surrounded by marrow. Sometimes it's called spicular bone, and of course these little pink osseous structures themselves, which do not contain the features found in dense bone, in other words the Haversian canals, are called spicules. So spicular bone is much more simpler than cortical bone, or cancellous bone is much more simpler than dense bone. Let's take a look at one of the spicules. In the spicule, you will not see Haversian canals or Volkmann's canals, but you will still see osteocytes. There's one, there's one, there's one, there's one, there's one. Oh, there's one, there's one. And then you see these cement lines, which are the crystalline aspect. The membranous bone or spicular bone or softer bone or cancellous bone or spongy bone is formed by osteoblasts appearing at the periphery of these spicules and then being trapped up within the spicule in a lamellar line or a lamellar fashion, and that is why you do not see Haversian canals and Volkmann canals. You see a more concentric or lamellar deposition of bone. But the principle is the same. You have these rims of osteoblasts on the outside of the spicule, and as it grows, these osteoblasts get trapped up within the middle of the spicule to become osteocytes. So let's take a look at something we could probably definitely call this cell, this cell, this cell as being definitely osteoblasts. As the bone is formed and they're trapped up within these concentric lines, these osteoblasts, like you see here and here and here, and probably along here, become then osteocytes, just like we saw it in Haversian bone also, and very similar to the way we saw chondroblasts at the periphery near the perichondrium become chondrocytes within the middle of the matrix. So this is a much simpler form of bone. This is spongy bone, and these spicules are separated from other spicules by either fatty marrow or hematopoietic marrow. And as you can see here, these cells are not fat, so even though there's a few fat cells, so this is hematopoietic marrow, and I thank you very much.